In this video, we're going to complete the KutaSoftware Infinite PreAlgebra free worksheet, one-step equations with integers. Now, I'll leave a link in the description below so you know how to access this worksheet. And if you want a quick refresh or explanation on how to solve one-step equations, check out my tutorial on maemap.com. That's maemap.com. Now, our instructions on this worksheet are to solve each equation. And what we're going to be doing is we're going to be solving for the variable. So what value does that variable have to be in order to make this equation true? So in number 1, v has to be what so that v minus 10 equals a negative 9? Well, I know that 1 minus 10 will give us that negative 9. So for number 1, our answer is 1. But let's start with some good practice and solve for v by moving and manipulating our equation. So v minus 10 equals a negative 9. If I want to solve for v, all I have to do is get rid of this 10. So I want to isolate v, meaning get it all by itself. So if I add 10 to both sides, because whatever I do to the left-hand side of an equation, so on the left side of the equals sign, if I add 10, I have to do that same thing to the right side. So I have to add 10 to the right side as well. That way, I keep the equation the same. Even though I'm changing it, I'm not changing the values. I'm just manipulating it. So if I have a negative 10 and I add 10, that's going to be v plus 0. And negative 9 plus 10, negative 9 plus 10 gives me a positive 1. And v plus 0, 0, remember, doesn't change the value. So v plus 0 is going to be v. So v equals 1. Again, 1 is our solution in number 1. Let's move on to number 2. And number 2, again, our variable that we're solving for is v. So we have to figure out what v needs to be in order to make this equation true. What minus 10 equals a negative 3? That's going to be 7, because 7 minus 10 equals negative 3, so v is going to be 7. Our solution in number 2 will be 7. But let's solve by manipulating the equation. So I have a minus 10 here, and in order to get rid of that, I'm going to add 10. So I'm going to do the opposite sign. Because this is negative, I'll add. If this was a positive, I would subtract. But we'll get to that later in the worksheet. So negative 10 plus 10, that's going to give me a 0. So v plus 0 is going to equal, now remember, whatever I do to the left-hand side of my equation, I need to do to the right-hand side of my equation. So the things on the left of this equal sign, because I added 10, I will also need to add 10 to the right side of that equal sign. Negative 3 plus 10 gives me a positive 7. V plus 0, again, adding 0 doesn't change. So v equals 7. Again, 7 is my solution in number 2. Now, in number 3, x minus 3 equals 4. This time, we're solving for the variable x. Well, what minus 3 equals 4? That's going to be 7. We all know that 7 minus 3 equals 4. So 7 is going to be our answer in number 3. But let's go ahead and solve by manipulating the equation. Because I have x minus 3 and I want to isolate the x, aka isolating, also known as getting that variable all by itself. I need to cancel out this 3. And because the 3 is subtracted, I'm going to need to add a 3 to cancel it out. So minus 3 plus 3, or negative 3 plus 3, that's going to be a 0. So I'll have x plus 0, or we could have x minus 0. Doesn't matter because adding or subtracting a 0 doesn't change that value. Now remember, whatever I did to the left-hand side of this inequality, I have to do to the right-hand side. So because I added 3 to the left, I need to add 3 to the right. So I have x plus 0 equals 4 plus 3 is 7. So x equals 7. Again, 7 is our solution in number 3. In number 4, we mix things up a bit because now we have x divided by 5 equals 2. But remember, we're trying to solve for this x. And we can do this really in our heads. What number divided by 5 equals 2? That's going to be 10. 10 divided by 5 equals 2. But let's solve by manipulating the equation because it's a valuable skill to have. So because I'm dividing by 5, the only way to get rid of that is by multiplying by a 5. So when we were adding or subtracting, we would add or subtract doing the opposite sign in order to add or subtract 0. However, we don't ever want to multiply something else by 0 because that changes the value and makes it 0. When adding or subtracting, we can always add or subtract 0, and that doesn't change the value. X plus 0 or x minus 0 is still x. But when multiplying, we don't want to multiply by 0 because then that makes our whole entire equation 0. But what's a number we can multiply where it doesn't change the value? That's going to be a 1. So if we multiply or divide by 1, we're not changing the value. So if we want to isolate this x, how do we make it so that it's multiplied by 1? All we have to do is multiply by 5, and I'll multiply by 5 over 1. And remember, whatever we do to the left, we need to do to the right-hand side. So look at what I just did. 5 times x is 5x over 1 times 5, which is 5. 5x over 5. The 5's will cancel out because 5 divided by 5 is 1. So that gives us 1 times x, which we said is x. So now we just have to figure out that right-hand side to figure out what x is equal to. So we have 2 times 5 over 1. 2 times 5 is 10, and 10 over 1 is equal to 10. Because 2 times 5 is 10, and 10 divided by 1 is 10. So x equals 10 is our solution in number 4. Now in number 5, we have 22 equals negative 11 times k. So negative 11 times what equals 22? A negative times a negative will give us a positive, so we know that k has to be negative, and 11 times 2 is 22, so k is going to need to be a negative 2. So we can do that thinking about it in our head, but let's manipulate the equation. Because these numbers are multiplied, we need to divide in order to get rid of this negative 11. So I'm going to divide by a negative 11. Dividing by that same sign, negative divided by negative is a positive, and negative 11 divided by negative 11 is going to be a positive 1. So I'll have 1 times k, and remember, whatever I do to the right, I need to do to the left. So I'm going to divide the left-hand side of our equation by negative 11. 22 divided by negative 11 is a negative 2. So negative 2 equals 1 times k, so negative 2 equals k. And usually we always put the variable on the left, so if you want to say k equals negative 2, that's perfectly fine. Let's move on to number 6. Now in number 6, we have negative 13 times m equals negative 377. Now this one's a little bit harder to do in our head, so let's go ahead and manipulate the equation. In order to isolate m and get that variable all by itself, because that's what we're solving for, we're going to divide by a negative 13. And whatever we do to the left-hand side, we do to the right-hand side of that equation. So divide the right-hand side by negative 13 as well. Negative 13 divided by negative 13 leaves me with a positive 1. And 1 times m is equal to m. So now all I have to do is negative 377 divided by negative 13. A negative divided by a negative is a positive, and 377 divided by 13 is going to be 29. So negative 377 divided by negative 13 gives me a positive 29. So 29 is our solution in number 6. In number 7, b minus 7 equals a negative 1. I'm solving to figure out b. And we can do this in our head, because what minus 7 equals a negative 1? Well, that's going to be a positive 6. But let's manipulate that equation to show that this is true. So if I'm solving for b, I need to isolate it. And because this 7 is subtracted, in order to get rid of it, I need to add it. So, as opposed to subtracting 7, I'm going to then add 7, and I need to add 7 to both sides. Because think about it, if I subtracted 7, a negative 7 minus 7 would be negative 14. So then I'd have b minus 14, which doesn't help me isolate that b. But negative 7 plus 7 is going to give me 0. So I'll have b minus 0, or you can think of that as b plus 0, which isolates my value and gives me b. And then if I have negative 1 plus 7, you can think of that as 7 minus 1, which is 6. So b equals 6 for number 7. In number 8, this time my variable I'm solving for is p. So we have negative 8 equals p minus 13. What minus 13 equals negative 8? That's going to be a positive 5. But let's show that. So since this 13 is subtracted, I need to add it in order to cancel it out. And whatever I do to the right-hand side of my equation, I need to do to the left. So because I added 13, I need to add 13 on the left. Negative 8 plus 13, you can think of that as 13 minus 8, which is a positive 5. And then p minus 13 plus 13 is p minus 0, or p plus 0. So 5 is equal to p, or p equals 5. That's my solution in number 8. Now hopefully these are getting a little bit easier the more we do, but if you're confused at any point, pause the video and put your question in the comments below, and I or one of your peers will respond as quickly as we can. For now, let's keep moving along. In number 9, we have negative 40 equals negative 5 times p. I know that 5 times 8 gives me 40, so negative 5 times a positive 8 will give me a negative 40, because a negative times a positive is a negative. So right off the bat, I can solve for this in my head. I know that p is going to be 8, but to show that, I need to cancel out this negative 5, and the negative 5 is multiplied to p. So in order to get rid of it, I'll be able to divide by that value. And remember, I know this is repetitive, but you need to remember this for future equation solving. Whatever I do to the right-hand side of my equation, I need to do to the left-hand side and vice versa. So because I divided by a negative 5, I need to do so on both sides of my equation. So negative 40 divided by negative 5, negative divided by a negative is a positive, and 40 divided by 5 is 8. So 8 equals 1 times p. So 8 is equal to p. Now for number 10, I have 418 equals negative 22a. The variable I'm solving for in this case is a. And in order to isolate that and get it all by itself, I'm going to need to divide by negative 22. Whatever I do to the right, I'll do to the left. So I'll also divide 418 by negative 22. A positive divided by a negative is going to result in a negative. So 418 divided by 22 is going to give me 19. So negative 19 is going to be equal to negative 22 times a divided by negative 22 is going to be 1a, or 1 times a. So negative 19 equals a. Now, for number 11, I have a divided by 29 equals 5. So what divided by 29 equals 5? Well, the way we would solve that, we can isolate that a, or get that a all by itself. So in order to isolate that a, I need to, because the 29 is divided, I need to multiply by it. So I'll multiply by 29, which is the same as multiplying by 29 over 1 if you want to line up your numerators and your denominators. And whatever I do to the left, I need to do to the right. So I'm going to also multiply by 29. Again, I can multiply by 29 over 1, but 29 divided by 1 is still 29. So because I don't have a fraction on this right-hand side, it's unnecessary to put it over 1. So rewriting my left-hand side, I have 29a all over 1 times 29, which is 29. And then on my right-hand side, I have 5 times 29, which 5 times 29 is going to be 145. Now notice that 29 divided by 29 equals 1. So 1 times a, or simply a, will equal 145. So 145 is my solution in number 11. Moving on to number 12, we have negative 2 equals m divided by 16. Isolating that m, because it's divided by 16 currently, I'll multiply by 16. And because I have this fraction, I'll multiply by 16 over 1. But remember, multiplying by 16 over 1 is the same as multiplying by 16. So I'll have 16 times negative 2 on my left-hand side, and that's going to be equal to m times 16 over 16. 16 divided by 16 is going to be 1, so I'll have m times 1, which is simply m for my right-hand side, and 16 times negative 2 is going to be negative 32. Negative 32 is my solution in number 12. And think about it. If we go back to this original, negative 32 divided by 16 does indeed equal a negative 2. Now for number 13, what minus 11 equals 16? That's going to be 27. I can do that one in my head. 27 minus 11 equals 16. So our solution is 27. However, let's manipulate this equation and solve. Since this number 11 is subtracted, in order to cancel out the subtraction, I'm going to add. Whatever I do to the left, I need to do to the right. So I'm also going to add 11 on my right-hand side. X minus 11 plus 11 is x minus 0, which is equal to 16 plus 11, which is 27. So x minus 0 is x, and 16 plus 11 is 27. So x equals 27 for number 13. Moving on to number 14, we have negative 10 equals x minus 21. Solving for x, all I need to do is get rid of this 21 to isolate it, and then I'll know what it's equal to because I'll have it all by itself. So if I add 21 to both sides, that's going to get rid of the 21 with my x, because x minus 21 plus 21 will be x minus 0, or x plus 0, which is simply x. It's just x all by itself. And because I have x all by itself, I'll know exactly what it equals when I solve this left-hand side. So I have negative 10 plus 21. Negative 10 plus 21 is going to be a positive 11. So x is 11, or 11 is x. And you can see that if we plug 11 back in, 11 minus 21 does indeed equal negative 10. That makes that equation true, so x must be 11. Let's continue on to the second page. So I have 20 equals n divided by 4. I need to isolate the n because n is my variable I'm trying to solve for. So what divided by 4 equals 20? Off the top of my head, I know that's going to be 80, but let's solve. In order to isolate that n, it's divided by 4, so I need to multiply by 4 in order to cancel that out. And just to keep my fractions in line, I'll do 4 over 1, which is 4. So on my left-hand side, I'll also need to do the same thing, so I'll multiply by 4 on my left-hand side, which 4 is the same thing as 4 over 1, but because I don't have a fraction, I don't need to write it over 1. So 4 times 20, that's going to be 80, and 80 equals n times 4 over 4 times 1, which is 4. Notice 4 divided by 4 is 1, and n times 1 is n. So 80 equals n. 80 is my solution in number 15. In number 16, I have n minus 29 equals a negative 53. So in order to solve, again, I'm isolating my variable, and in this case, my variable is n again. So because that 29 is subtracted, I'll need to add in order to get rid of it on the left-hand side, so that my n is all by itself. Whatever I do to the left, I need to do to the right. So n minus 29 plus 29 is going to be n minus 0, which is simply n, and that's going to be equal to negative 53 plus 29, which is a negative 24. So n equals negative 24 makes this equation true in number 16. In number 17, I have negative 19 equals b minus 6. So what minus 6 gives me negative 19? That's going to be a negative 13. But let's solve by manipulating the equation. So because I need to solve for b, I want to isolate it and get it all by itself, which means I have to get rid of this minus 6. And in order to do that, I'll add 6, because if I'm subtracting 6 and then I add 6, that's going to be 0. And b minus 0 or b plus 0 is simply b. And remember, whatever I do to the right, I do to the left. So I'll add 6 to the left-hand side as well. Negative 19 plus 6 equals a negative 13. So negative 13 is equal to b. Now for number 18, I have negative 8 equals negative 16 plus n. Negative 16 plus a positive 8 will leave me with a negative 8. So I know that n has to be 8. Negative 8 equals negative 16 plus 8. I know this to be true, so I know our answer is 8. But let's solve to see if we get the same thing. In order to isolate the n, I'm going to need to get rid of this negative 16. I'll need to add the positive 16 to get rid of it. Negative 16 plus 16 gives me 0. So I'll have 0 plus n, and that's going to be equal to, remember, whatever I do to the right, I need to do to the left. So I'm going to add 16 to negative 8. Negative 8 plus 16 gives me a positive 8. So I have that 8 equals 0 plus n, which is n. So 8 is definitely my solution in number 18. And you can see that it does indeed make the equation true, or make the equation valid. And when I say true, it means if I plugged in any other number, let's say I plugged in 2 for n, negative 16 plus 2 gives me negative 14. That does not equal negative 8. But when n is 8, we do get negative 8 for negative 16 plus n. So now jumping into number 19, what makes this equation true? Think about it. If we made x a negative 1, negative 9 plus negative 1 would be a negative 10. And negative 10 does not equal negative 26. So there's some value for x that will make this equation valid or true. What does that have to be? Well, just by thinking about this mentally, I know that negative 9 plus a negative 17, yeah, because 9 plus 17 is 26, so a negative 9 plus a negative 17 will equal a negative 26. So solving for this equation is the value that makes this equation true or valid. So when x is a negative 17, negative 9 plus x does indeed equal the negative 26. Any other value for x will not work. So we're solving for that specific value that makes this equation true or valid. Now we know it's negative 17, but let's use the methods that we've been practicing on this worksheet to solve. So that's isolating x. And because negative 9 is added to x, I'm going to add a 9 that's positive to get rid of it, because negative 9 plus 9 gives me 0, and 0 plus x is equal to x. But for now, whatever I do to the left, I need to do to the right. So I added 9 on the left, I'll add 9 on the right. negative 26 plus 9 is a negative 17. So x is equal to negative 17 for number 19. Now again, for number 20, this is easy to think about. 29, if we're adding that to our variable n, what does n have to be in order to equal 13? In order for the left-hand side to equal 13? Well, 29 is greater than 13, so n is going to be negative. And what do we need to subtract, or what value do we have to add that's negative to 29 to get 13? And that's going to be a negative 16. That's the only number that will make this equation true. And to go ahead and show that, we're going to isolate n by subtracting 29 since it was added and it was a positive. Whatever we do to the left, we'll do to the right. So 0 plus n, which is simply n, is going to equal 13 minus 29, which is negative 16. So negative 16 is our solution for number 20. Now, moving on to number 21, in order to isolate that x, right now you can see that it's divided by an 18, and in order to cancel that, I'm going to need to multiply by an 18. Or, since this is a fraction, I'll do that as 18 over 1. But remember, 18 over 1 is the same thing as multiplying by 18. So on my left-hand side, because I don't have that fraction, I'll just multiply by 18. So now you can see that x times 18 over 18 times 1 is x divided by 1, or x times 1. So I have x equal to 18 times 21, and 18 times 21 is going to be 378. So 378 is my solution in number 21. In number 22, what plus 1 equals a negative 27? That's going to be a negative 28. But let's show that work. So in order to isolate the k, I'm going to subtract 1, because k plus 1 minus 1 will be k plus 0, which is k. And if I subtract 1 on the left, I need to subtract 1 on the right. Negative 27 minus 1 is a negative 28. So negative 28 is my solution in number 22. Now for number 23, 6 equals something, our variable m, which we're going to solve for, minus 16. What number minus 16 equals 6? That's going to be 22. But let's go ahead and show our work and solve. So add 16 to both sides, because whatever I do to one side, I need to do to the other. 6 plus 16 is 22, and 22 equals m minus 0. And m minus 0 is m. So 22 equals m for number 23. In number 24, we'll go ahead and solve this one-step equation. So it's going to take us one step to solve, and that's going to be subtracting 29. That's our one step. There we go, because v plus 29 minus 29 is equal to v plus 0, which is v, and 5 minus 29 is going to give us a negative 24. So in one step, we solved and got negative 24 as our solution, and that's what v needs to be in order to make this equation true, because negative 24 plus 29 equals 5. Any other number will not work. So now, looking at 25, we have 168 equals negative 84 times n. Because that's multiplied by n, in order to isolate n, I'm going to have to divide by that same value. So dividing by negative 84, I divided because negative 84 divided by negative 84 is going to be a positive 1. And 1 times n is going to be equal to n. Now whatever I do to the right, I need to do to the left, so I'll also divide 168 by negative 84. A positive divided by a negative is going to result in a negative. And 168 divided by 84 is 2, so that's going to be negative 2 as my value for n in number 25. So negative 84 times negative 2 equals a positive 168. On to number 26. We have 41 times k equals negative 2,747. So what value does k have to be in order for 41 times that value to equal negative 2,747? The easiest way to do this is simply divide by 41 and divide by that on both sides. 41 divided by 41 is 1. 1 times k is k. So a negative divided by a positive is going to result in a negative, and 2,747 divided by 41 equals 67. So negative 67 is equal to k for number 26. Now on to the second to last problem, number 27. Again, if you have any questions, please leave them in the comments below, and I'll get back to you as soon as I can. Also, just a friendly reminder, if you're finding this video helpful, give me a thumbs up. And go ahead and share with us with your classmates or peers, because if you're finding it helpful, chances are they'll find it helpful as well. Now, in number 27, we're going to solve for x. There's one number where if we divide it by 15, we're going to get 11. So let's figure out what that number is. In order to do that, we need to isolate x, get it all by itself. So if I multiply by 15 over 1, and let's make this a little bit easier to see, I'll cover up that number sign. So 15 over 1, that'll be 15x over 15. And whatever I do to the left, I need to do to the right. So because I multiplied by 15 over 1, that's the same as multiplying by 15. So 11 times 15 is 165. So x is going to be equal to 165 because 15x divided by 15 is 1 times x, or x divided by 1, which is x. So 165 is our solution for number 27. Now, lastly on this page, number 28. We have negative 71 equals x divided by 64. So what number does x have to be? Well, the easiest way to do this is just to multiply both sides by 64. And when we multiply both sides by 64, we'll isolate that x and get it all by itself, because 64 divided by 64 is 1, and x times 1 is x. So now we just have to do this left-hand side out. 64 times negative 71 is going to be a negative, and that's going to be a negative 4,544. Now let's double check and make sure this is true. If we put negative 4,544 in for x, and then divide that by 64, we do indeed get negative 71. So negative 4,544 is our solution to the last problem on this worksheet. Again, if you have questions, put them in the comments below. And if you want more ways to support me, go to my website, maemap.com, that's maemap.com, or become a patron. Click the link in the description below to find out more information. But as always, don't forget to like, subscribe, and share. Happy learning!